Hi, my name is Ed Doherty. I'm the CNC Precision Machining instructor at Suncoast Technical College in Sarasota. And we're also a Mastercam University education facility and a Haas Technical Education facility. And we make all kinds of machine products, but today we're going to talk about the CO2 dragsters. We have a whole bunch of different ones, and we're just going to show a little bit about how to set up and run one. So I'm going to do this from point of view of my hat. This is the Techno CNC router machine. Comes with a IMS Technologies fixture. We made one modification and we changed the bracket on the back. We no longer hammer this piece in here. We literally just screw this on, and this will keep it attached, and will still rotate and position properly. Okay, so we put a couple of wood screws in here, because if you look at one of these other test pieces, this area here will be cut off, so it's not being used. Also, when we set up our fixture, we went to the limits of travel. So right now I have this homed out, and I'm going to move it in the X direction. Okay. And that is coming up, that's about the limit of travel right there. So, if we were to look at this, we are way beyond where we need to be. We would not get into this area. And I'll tell you why we want to be shifted this way. Let me get my tape measure out. Get some numbers on this. Excuse me for a second. There we go. So the tape measure is about 4 inches of overhang if you're using this fixture. I'm going to put this back to the home position. I have the software in here. I hit home, home all. Okay, now this is going to home out. And I also put a table. This is from, on our Haas CNC machines, we're usually facing it from this view, and our X and Y coordinates would go in this direction. So X plus is this way, X minus, Y plus, Y minus. So this is looking from the spindle's point of view, or looking down the top. And so we'll be looking down the Z-axis. So when you're in Mastercam or your orientation, you're looking at it this way. And we're using this back edge here is our X0. And the center line of the CO2 cartridge is the Y0. And if you're using the CUDA country tutorials, you're setting all your tools 34 millimeters from the center line of this. So to do that, they give you a fixture right here. This end mill and drill. We've been just using the end mill. So we had to calculate this distance from here to center line of axes and add 34 millimeters to that. I think I have some notes here that I believe it's 45 millimeters from here to here and add the 34. So we took a dial caliper, or a height gauge like that would work. Let's get a dial caliper. Can we find one around here somewhere? Okay, we have a dial caliper, and I'm fully prepared here. And a calculator. Okay. Because we're in the United States, we're burdened with having to use the English and metric system, and all our measuring instruments are in English. So we have 45 millimeters plus 34 equals 79 divided by 25.4 equals 3.110. I believe we made and that 45 millimeters is rounded off. I think we made an adjustment and we are running at 3.0, almost, let me re-zero this gauge, 3.048. So I'll have some, on my blog, I'm going to have some hard numbers, but this is basically what we're looking at. So we've preset this, you tighten this down, and we're going to touch off the tools off of this surface. So, right here, I'm going to jog that over there. We're not going to crash on top of it. We're going to bring it over, close. I'm going to slow down this feed rate. Now it's going to move slower. Okay, slow it down even more. This is Z up and down. And when we get it close enough, we're going to go into step mode, which means take it out of continuous. And step size will be every time you click this, it'll go that amount. So what we're going to do is slide this underneath. We're not going to come down and crash on top. You keep on clicking this button. As we get closer, try to pass it underneath one click at a time. Right. One more. I think one more. One more. Right there. We're a little bit, I'm hitting it now, so I'm going to go up one click. And that's my setting right there. So that is minus 12.450. So you should write all these down just in case, because you're going to put it in your settings. Let's get a writing instrument. Handy writing instrument here. There we go. Tape measure, and this is a master camp setup sheet that I made to show orientation. So I'm just going to write some notes in the back. There was some other notes here we were writing about. Here it is. 45 millimeters was 1.775, 34. So that was our original setup. Anyway, today's date is 3/8/18, and my Z minus number was 12.450, and I did this after I've homed the machine out, so I have reference. So these are all I'm going to enter into my configuration file. So next thing we need to do is take it out of continuous, and we're going to go, it's kind of noisy, speed it up a little bit. Alright, we're going to set the X coordinate. Now, how accurate can you get this? We need the center line of this spindle to be over this coordinate here. It may actually be helpful to use a mirror. Might save some steps. Okay. So I'm looking at it from this point of view. So I'm going to bring it down a little bit. Okay. Move it in the positive direction. But we're looking at it from this point of view right here. Alright. I'm just going to do a quick guesstimate. You could be totally accurate, but you want to have everything mounted in here when you do this, because this is going to determine where this is going to be. And I don't think it needs to be that accurate, because you can do some fine-tuning work. So I'm going to put it in the step mode, which is non-continuous, and keep it going in the direction. Double check myself, and I think we're about on center line. So that's my X. I'm gonna write that down. That is 24.23 millimeters. X 24.23. Okay. Now we need to set the center line of this axis, this shaft right here. Now I have everything mounted in here. I really don't want to take it out. But what I did previously, and it was probably good when I had a machine piece, I'm going to take it out of continuous, move it to the left. You're very tight here, right here. We've actually moved the unit up as far as we moved this motor up. You really can't move this. Well, we haven't attempted to, but we're trying to gain as much room as we can. So we've got it so that the collet is pretty even with the bottom of this piece, because sometimes you get very close to hitting this. Make sure you have none of these hard screws on top that this can interfere with. And the other thing we modified was we're using this screw to be our orientation device. So that ball screw aligns with the grooves that are cut in this, so that will be our orientation. So when we go to orientate this is fully in right now, and we'll move this, and this will be our orientation right now. So you want to get this as level as you can to your table, so that the part is not too twisted. You can fine tune it a little bit by undoing the clamp and moving it on this pivot, but it's best to have it aligned to where this screw aligns with the slot that's machined in this piece here. So we're not too bad there. You probably could use some tweaking, but this is orientation for 0 and 90 degrees and 180 degrees, and these are clamping it in place right there. Deliberately move that out of the way. So this will be the other side. So usually you're cutting left side first. You would clamp that in place. You would clamp these two down and butt this all the way up against there. So then when you go to rotate, you gotta loosen those up, back this off all the way, rotate all the way around, feel where the little groove is right there. Make sure you have it pulled back all the way. Tighten, tighten. That's all you need. You don't need to hammer this in. This is going to hold everything. Okay, so going back to our setup, we need to find center line. So what I had done originally was I took the shaft, or you can even take a broken one of these. This is a 6mm ball end mill, which in English is .236. And what we did is we brought it down without this piece of wood in the way, and we slowly came up until we could get a piece of paper or a feeler gauge. I prefer to use a feeler gauge. And we would just rotate this so I can feel it grab. And I know this shaft, I believe, is 750 diameter, .750 or 3/4 of an inch. So you can calculate your way to the middle, and you have to go by this Y coordinate. So I believe we came up with 103 millimeters from Y home to here. Okay, so I'm actually going to orient this, orient that. I'm sorry, I should have locked this down, and we're doing left side first. Left side first, push, clamp, clamp. We're doing this side first. We've moved the motor up, and let me get you some numbers on that. So if we go all the way up, I go to home, and I'm going to home Z only. We're trying to gain as much room as we can here for clearance moves, just in case you need to go down farther, and then you won't have an issue with crashes. We're more than able to reach very far without this in the way, so the more you can sneak this up in the air, the better off you are. You may have to extend this tool if you need more length, or get a tool with more cutting flute length if you need all that depth of cut, especially if you're doing any internal cuts like wheel cuts inside. This one got buried a little bit, so you may, if in that case, you might have to do some roughing profiles and not just finishing profiles. With more tool, more cutting edge, more length of cut, we call this right here. Okay, so that's pretty much ready to go. So my configuration file, I'm going to exit jog, and I'm going to go to configure defaults, and I'm running metric, so I'm running all hundreds here. And I can set my speeds, but what I want to do is I want to return to 0, say yes, and home before, say yes. And that will help you. So here is where we're going to put this X offset. We are now, we used to be at 13.25, we moved the fixture down, we have more room. 24.23, oops, sorry. 24.23, maybe I should put the number lock on. 24.23, there we go. We're keeping 103, and my Z offset is now minus 12.45. Save changes. Alright. Make sure they get saved. And double check this stuff, because sometimes it doesn't take. 3 100s will give you metric. Rapid speed 1504. So you can change all these speeds to maybe rapid's going to be non-cutting, so. And this is in millimeters per minute. This is like a default. We've tried 450 and 300, and the override speed we put yes. So I'm going to save changes. Okay, so next thing we're going to do is download our program. So we got our tools.